listeners. I'm here, Dr. Hilal. So today we are going to talk about carbon and its compounds. It's a very important chapter in our 10th. So here we are going to study the basics. It is not only regarding the carbon, but it will just give us much more knowledge, and it will improve our knowledge about overall chemistry. So we know that chemistry can be divided into three main parts. Number one is physical chemistry, and we have inorganic chemistry, then we have organic chemistry. So if we want to study the chemistry, so we divide it into three main parts. Number one is physical chemistry, then we have inorganic chemistry, then we have organic chemistry. Okay, physical chemistry means this chemistry deals with like solid, liquid, gas, where we are going to study the physical nature of the things. Okay, inorganic chemistry means the part of chemistry which deals with compounds which are formed of other than carbon and its compounds. Okay, we have a series of elements in the periodic table from hydrogen to the one. There, if we want to study those compounds, their nature, their structure, and these what compounds they make and what is the nature of those compounds and function, everything that comes under inorganic chemistry. Then we have one more important field of chemistry, that is organic chemistry. Organic chemistry is whole and solely the chemistry that deals with carbon and its compounds. So it means in chemistry this carbon is having one important role to play, because of which only it has been divided, or it has been set in a separate group. Okay, so it means if you know about carbon, it will open you the doors to have an understanding about full organic chemistry, because some people they are doing their higher study in part of the chemistry only, that is organic chemistry. Even in the MSc project, you have to design your project in only one field of these three. So in PhD, solely go in one field only. Okay, so this is very important part of our chemistry. That is why we should know why it has become such an important thing and why it is so famous. Okay, let us first discuss about carbon itself. Carbon atomic number, we should know atomic number 6. So we know that what is atomic number? Atomic number just it represents the number of protons present in that element. So the atomic number of carbon is 6. When we talk about atomic number is 6, so let's see its structure. Okay, this is nucleus, and after nucleus we have the first shell. In this shell we have 2 electrons, and it is outermost shell, it has 4 electrons. So 2 plus 4 equal to 6. So total number of 6 electrons it has. Okay, its mass number is 12. Okay, mass number means the number of protons plus the number of neutrons present inside the nucleus of an element, it shows the mass number. Okay, so number of protons in carbon is also 6 only. Okay. It occurs in the free state also. Free state means as a pure carbon also it can be present, or it is combined in the present in the combined state also. Combined state means what? It is available with in bond other elements, the compounds. Okay, then we have to know that of our body 70% of human body is made up of carbon only. So our body itself is also 70% made up of carbon only. So it is a surprise for us. This carbon forms the largest compounds on earth. Largest compounds, number of compounds it forms on the earth's crust. But still we have only 0.2% of carbon, so 0.02% forms the earth's crust. Okay, so because of this carbon we came to know what is organic chemistry. So what are organic compounds? What are organic compounds? The organic compounds are the compounds consists of carbon essentially, which consists of essentially carbon and hydrogen. So in organic compounds we have carbon and hydrogen. These are the essential part of the organic compounds. So it can be with some other elements like oxygen, sulfur, nitrogen, okay, nitrogen, even phosphorus and halogens. Okay, so the compounds, these elements with carbon and hydrogen, they form the organic compounds. Okay, these compounds, when we talk about carbon is attached with some compound, it is attached, all these compounds are made because this compound, when more than one element they come together in a fixed ratio, okay, they form a compound. For example, water is a compound H2O water, where two hydrogens they are joined with oxygen. Likewise we have different we have the ocean of compounds. Okay, the thing is now what makes these compounds is the chemical bond. So two elements, they are attached or they are joined together by a force, that is chemical bond. So now what is chemical bond? It is a force attraction that holds two elements together. So this element 1, this element 2, something holds them together to form a compound. Okay, so this something, this force, by they are attached with each other, is called chemical bond. Okay, this chemical bond in the compounds is mainly of many types. So we can have many types of bonds, but one of the famous bond which carbon makes the compound, the covalent bond. Covalent bond. What is covalent? Covalent bond is also a type of force. Okay, it is the bond formed by the where we have equal sharing of electrons. In covalent bond, what we have equal sharing of electrons. So what does it mean? Is if there is one like we have, let us see the structure of oxygen and how it is attached with the hydrogen to it is bonded with the hydrogen to form the H2O. Actually, this in the first shell of this hydrogen there are two electrons, but this hydrogen is having only one electron. This hydrogen is also one electron. So this oxygen is having two valence electrons. So we will come to know what is a valence electron. Okay, electron by which can those electrons which it can share the other elements to form a compound. So this oxygen is having two extra, but hydrogen needs one. So it means it is having one only, so it will share it with the hydrogen. This is not oxygen. So like this hydrogen is also sharing, it is one of the bond with the one of the electron with the this oxygen also sharing, it is two electrons. Okay, like this. So oxygen got 1 2 2, then each hydrogen got one electron. So by this way they are bonded. Okay, so this equal sharing of the electrons we can see in what type of bond? It is covalent bond. Okay? So we can understand also it can share the this sharing is not only always the other compounds like we say hydrogen, oxygen, even hydrogen. If we see the H2 gas, hydrogen is always present in H2 form. Here we have hydrogen 1, it is having one electron, hydrogen one hydrogen is having one electron. So both of electrons, both of these hydrogens, they are in need of one extra electron, so as to complete their first shell. In the first shell there should be two electrons, that is must, so that it can be balanced. Okay. So what it is doing, this hydrogen is sharing, it is one electron with the other hydrogen. So this hydrogen also is sharing, it is electron. So this becomes the electronic sphere of this hydrogen. This is now the electronic sphere of this. So here we saw as force which just bonds these two hydrogens can be called as covalent bond. Covalent bond. Okay, this is covalent bond. So this bond between the two hydrogen formed by the sharing of electron is called now covalent bond. Okay, let's see what is covalency. This about, since we are talking about carbon, this carbon, as I said before itself, it has 4 valence electrons. Valence electron means in its outermost shell it is having 4 electrons. 1 2 3 4 electrons. Okay, these 4 electrons, very high amount of energy is required to lost the 4 electrons. It can lose them also, but to lose it, so we need some more energy from the external source to remove the 4 electrons. You understand? So we require to lose this so that we can form C4 positive. 4 positive means it has lost the 4 electrons. There is a strong force of attraction between the nucleus and the valence electrons. Inside we have nucleus. In this nucleus and the valence electron, it is having a strong. Why? Because inside we have 6 protons, outside also 6 electrons. So protons are positive in nature, electrons are negative in nature. So there is the positivity and negativity, it is maintained by this way. Okay, the carbon cannot gain 4 electrons also. Now it needs 4 electrons to complete its outermost shell, because we know that in the shell we should have 2 electrons, in the second shell we should have 8 electrons, in the other shell 8 electrons, like that we know that. Okay, so in the second shell it needs 8 electrons, sorry, it needs to complete its second, it needs 8 electrons. These 4 electrons which it needs in the outer shell now to complete the shell, it cannot gain also these 4 electrons. Why? Because inside there are how many? There are only 6 protons. 6 protons or 6 positive charges are present. Outside we give more 4 electrons, so it will not be balanced. You understand? So this is one of the problem here, because the 6 protons cannot hold the electrons. Okay, the 6 protons which are present inside the nucleus, they can hold the 10 electrons outside it. Okay, and there will be strong inter-electronic repulsion also. So carbon, now what it is doing a thing that is called sharing. Carbon is sharing these 4 electrons easily with the other atoms of carbon and other elements to acquire a stable electronic configuration. So what it do, like here we see water, this oxygen needs 2 extra electrons. These 2 extra electrons, it is shared with 2 hydrogens, 1 hydrogen and 1 hydrogen. Okay, so this sharing is done by the bond called covalent bond, by using the covalent bond. So in a single covalent bond, it is formed by sharing of one electron only, okay, of each atom. Like we saw in case of hydrogen, it is only 1 electron. So we have a single covalent bond here. Okay, then what about the double bond? So when we can say the bond is double, when there is the sharing of two electrons with that same element. For example, this is carbon, this is also carbon. It means these 2 carbons, they are sharing 2 electrons. It is getting the 2 electrons from this. It is by this way, this bond will be called as double bond. Likewise, we have the triple bond, in which the sharing of 3 electrons with the same element takes. So this double bond we can see in case of oxygen. We have oxygen O2. In O2, what is there? This is 1 oxygen, 1 oxygen. So these 2 oxygens are attached with each other by the sharing of 2 electrons. Okay, so way it forms a double bond. Now we have nitrogen. Nitrogen is having a triple bond with other nitrogen. Okay, when we are talking about N2, so this is 1 electron, 3 electrons of 1 nitrogen are shared with the 3 electrons others. So complete the outermost shell. How does this take place? This we are going to study in the next chapter. Okay, now about hydrogen molecule, I said when 2 atoms of hydrogen share 1 electron each, a single covalent bond is formed. Here we saw how it is formed. Okay, and then we have the chlorine molecule also in the same way. So this chlorine molecule, why we are studying these things, actually they are very important requirements in our chapter. Okay, we should know about this. So chlorine, Cl2, chlorine, the symbol for is Cl, capital C, small l, chlorine. Okay. This chlorine has actually 7 valence electrons. How many? 7 valence electrons. Valence electrons are the electrons which are present in the outermost shell of this element. Okay, so it has 7 valence electrons. So how many electrons are required? As I said, we need 8 electrons to complete one shell. It is having only need of 1 electron. Okay, chlorine is having need of 1 electron, but when we talk about Cl2, 2 chlorines are present. It means that it can share 1 electron with other chlorine atoms to form the chlorine molecule. For example, we have like this Cl and we have Cl, chlorine. So 1, 2, 3, 4, 5, 6, then 7. Okay, likewise we have here 1, 2, 3, 4, 5, 6, then 7. So chlorine, it is sharing, it is getting borrowing electron from chlorine. This chlorine is also borrowing electron from other chlorine. So it gets the complete 8 electrons in the outermost shell. Okay, this chlorine also gets the 8 completes its outer shell by sharing the 1 electron and borrowing it from other chlorine. So this is the structure of chlorine. So we write here like this: chlorine single bond chlorine, chlorine bond chlorine. Okay, likewise if we want to know HF means hydrogen fluoride. So these compound which is made up of hydrogen and fluorine. So we should also know that this when the hydrogen of share 1 electron with 1 electron of fluorine, hydrogen accepts 2 electrons, as fluorine gives 8 electrons to become stable. They form the single covalent bond. How? This hydrogen is in need of only 1 electron. The fluorine is having, like chlorine, it is having 7 electrons in its outermost shell. 4, 5, 6 and 7. 1 electron is shared hydrogen. So hydrogen is now occupied because it needs 1 electron only. Then this fluorine, see here, this fluorine is sharing the 1 electron, so as to get complete outer shell, that is 8 electrons. So this is the structure of hydrogen fluoride here. Hydrogen F is the hydrogen fluoride. Okay, very good. So let us see the structure of water, H2O. How we say this H2O. In water, what happens actually? The formation of water, each hydrogen atom shares 1 electron with the oxygen actually. Oxygen atom. So the oxygen completes its octet and hydrogen is the nearest noble gas configuration. You understand? So we have here like the structure. This is our hydrogen. It is having 1 electron in the outermost shell to acquire the noble gas configuration. Noble gas configuration. What does it mean? Students, if you are a little bit aware about periodic table, the periodic table, try to understand that we have the last here, the last set of these elements which are present on the I am not here to draw the full electron this periodic table. Suppose this is periodic table. Okay, so these are the lanthanide actinides, these are elements, these are the alkaline earth metals. Okay, then we have here the last column here, it is the noble gases. Important property of noble gases which makes them noble gas is that their outermost shell of these elements is simply with 8 electrons. They don't need any electron more. They are stable. They cannot get bonded with any other element. It's very hard to bond them with element. Because their outermost electrons, they have been equally they have got the octet configuration. Octet means outermost. For example, if we talk about in this sequence, we have helium, then we have this neon, xenon, like that. We go. So these are the different noble gases. They are called noble gases which fall in this. These noble gases, as I said, they have important property that their outermost shell is complete. They do need any further electron to be shared or to be gained or to be given to the other element. Okay, so each and every element has to share its electrons so as to get the noble gas configuration, that is a stable configuration, to become stable. Here in water also, this hydrogen needs to become a noble. The nearest noble gas is helium for hydrogen. In helium we have most electrons, two electrons are present. So this is full doublet. Okay, no of entry, one more electron here. So hydrogen also wants to reach the helium like situation, so that is why it is one outermost electron. So here we have water, H, this is HO, then I will again write the H here. Hydrogen with its electron, this is oxygen with it is how many electrons? This oxygen is having how many electrons? It is 6 electrons in this outermost shell. 1 2 3 4 5 6. So the thing is becoming like this. See how it is getting rid. This hydrogen is sharing, it is only one electron with the oxygen, and this oxygen is sharing, it is 2 electrons with 2 hydrogen. So in this way we can say that the oxygen is also getting noble gas configuration, and each 2 hydrogens are also gaining noble gas configuration. So if we want to see the structure, it will be written like this: oxygen bonded with each of the hydrogens. Okay, likewise we have the structure of some other elements, like we should know the structure of hydrogen, what is the structure of oxygen, okay, then what is the structure of nitrogen, okay, then what is the structure of ammonia, what is the structure of ammonia means NH3, okay, NH3, it is bonded there. Then we will come to know what is the structure of methane. So methane here means what? Methane means a structure compound which is formed of carbon attached with 4 different types of hydrogens. 4 hydrogens. So this forms, if we start writing it, it will become like CH4. Carbon attached with 4 different hydrogen molecules. Okay, so in methane we know that this carbon is having 4 valence electrons, 1 2 3 4, as I discussed before. This outer is having 4 electrons. Each hydrogen is having 1 electron, valence electron. So this carbon will share these 4 electrons with any element or any molecule. So here we see the case of hydrogen, how it is getting with the hydrogen itself. Okay, so this hydrogen got its full electrons, 2 electrons. This hydrogen also, we have this hydrogen also. So here also we got. What about carbon? Yeah, carbon also getting all the octet configuration now. The noble gas configuration. It has now sharing method. It has now 1 2 3 4 5 6 7 8 electrons. It is in its outermost circle now. Okay, which it is shared with the 4 different hydrogens. So this forms a compound called methane. Methane is very important, so we are going to see the properties of this methane in our next series. It is not only methane, the carbon can form one more element like ethane. In ethane, what we have here, we have only 1 carbon, here we have 2 carbon, single bond carbon. So how many are left now? 1 2 3, 1 2 3. So these 3 bond electrons will be shared with 3 different hydrogens. So this gives rise to the ethane. So the sharing of electrons is this only here. If we go deep, each and every element is gets its outermost shell complete as the noble gas configuration. Okay, so we have here the structure. We give the formula it like this: C2 1 and 2 H 1 2 3 4 5 6. So H6, this is 10. So this is our ethane. Likewise we can have. Now what we can do, we can remove any of the hydrogen here. If we replace this hydrogen with chlorine, what it will form? We will add chlorine and we will remove it with hydrogen, so it will become CH3Cl. It is C. Okay, C. Here we have hydrogen, and here it is chlorine. Chlorine is sharing as chlorine has already shared with its own. Okay, chlorine as a fluorine has shared with the hydrogen here. So it is a little bit easy to understand also. Okay, how does this sharing takes place? We can have here, if we replace one of hydrogen in it and by chlorine here, we can have a C2H5Cl. So what it is actually? It is ethyl chlorine. Here we say this term as methyl chlorine. Methyl chlorine. This will be called as ethyl chlorine. Why? Because ethane chlorine to the ethane chlorine was added, so we call it as ethyl chlorine. Then we have this. If we replace now all the 4 hydrogens here by chlorine, so the structure becomes like C carbon chlorine, one side also chlorine, this side also chlorine, this side also chlorine. So what it will be called? It will be called as one tetra, tetrachloride. Okay, CL4, carbon tetrachloride. So what is carbon tetrachloride? Yeah, here we have one carbon in the center. It is surrounded by 4 chlorines. Chlorines are sharing, as we saw, when they are sharing with each other. Okay, so the outermost, since chlorine is having 7 electrons in the outermost, 1 2 3 4 5 6 and 7, like 1 2 3 4 5 6 and 7, 1 2 3 4 5 6 and 7 here. Carbon is having 1 1 1 4, 1 2 3 4. The outermost is shared with the one chlorine. Here also it gets share, here also it gets share. Also 8 octet configuration. Each chlorine is getting it is octet configuration. So this is all about this. Let us move to the double covalent bond. So this we talked about single covalent bonds. We should know about double covalent bonds also. In double covalent bond, there is nothing new, just the sharing of 2 electrons takes place with the same element. Okay, when 2 atoms share 2 electrons, to occur the electronic configuration, double covalent bond is formed, and it is mostly denoted by the 2 lines. We have many examples, like as I said, it is oxygen. Oxygen is written actually here like this: oxygen, double bond, oxygen. Okay, oxygen. Then you have some more examples which you can yourself create and give for double bond. Then if we see in sub double bond, for example, can carbon also become a double bond with one more carbon? Yeah, it can. Why not? So if we have a situation like this, carbon, double bond means 2 electrons are shared with the same, with one this. We have one more electron here, one more electron, one here. We don't have 1 3 4, 1 2 4. Let these 2 electrons be shared with hydrogen. Okay, one hydrogen. So the structure is now C2 carbon 1 carbon 2 H1 2 3 4 H4. So what is called? It is called ethene. It is called ethene. E and E we use mostly for double bonds. Okay students, I hope you understood, and we are mostly writing it like this, C2H4. Then we have one more important compound that is existing in our environment, and we're more concerned with, that is carbon dioxide, CO2. This O should not be small, it should be capital Y, because when we are writing the symbol of each and every element, first letter should be capital. For example, if I'm writing helium, I know the helium symbol for the helium is He. First will be capital, second will be small. Okay. When we are talking about compound, for example, I want to write sodium chloride, Na, sodium and chloride, Cl. So I will write NaCl, capital C, small l, capital C, NaCl. So C, why? Because these are the different elements which I have to start with caps. The second will be with the small letter. So carbon is capital C, small capital O, O2. Okay, what is its structure? Yeah, it is very simple. Like here we have one carbon and two oxygens. Let one oxygen be one side, one oxygen be one side. So each and every oxygen, we know that it is having two outer electrons to be shared. Okay, to get it is to attain its octet 1 2 3 4 6. So electrons, number of electrons in the outermost shell of oxygen 6, number of electrons in the outermost shell of carbon 4, 1 2 3 4. Okay, 1 2 3 4. So here also see 6. So for oxygen to attain the noble gas configuration, and for carbon to attain the noble gas configuration, each of these elements, they require how many electrons? They require, this oxygen requires 2 electrons to be shared with some other element or elements. Carbon also 4 electrons to be shared with one element, one individual elements or the same elements. Okay, we can have here C carb oxygen making the bond like this. Like here we can have it is sharing the electrons 1 2 3 4 5 6 7 8. Now carbon is also not silent, it is also having, it's completing its octet, that is the outermost shell is getting 1 2 3 4 5 6 7 8. So 8 electrons, also 8. So this is the structure of carbon dioxide. So if we write here, actually carbon and carbon dioxide will be written like this, and in simple way the formula we write here CO2, carbon O2 1 and 2, carbon 2, 1 carbon and 2 oxygen. Same now the concept of triple bonds, triple bond formation. How does triple bond formation takes place? It is nothing we have in triple bonds, it is not now new to us, we can understand now because we know about single bond was formed, how double bonds were formed. Likewise we can understand now how triple bonds are also formed. Triple bond formation, when an atom shares the 3 valence electrons with each other or atom, triple covalent bond will be formed. It is mostly and it is denoted by like 3 lines. Okay, 3 parallel lines. So this denotes the triple bond. For example, you have triple bond in many elements, molecules, and in many compounds. For example, we have nitrogen N2. I discussed it before itself. So in nitrogen has actually 5 valence electrons. If we see the electronic configuration of nitrogen, in first shell it has 2 electrons. Since the atomic number for nitrogen, hydrogen, helium, lithium, beryllium, boron, oxygen, nitrogen. So it is 8. Out of the 8 electrons, 2 electrons inside, and how many electrons are outside? Yeah, how many means 5 electrons are remaining. No, sorry, hydrogen, helium, lithium, boron, carbon, nitrogen, sorry, I am talking about nitrogen. So nitrogen is having only how many? 7. The atomic number of nitrogen is 7, so it will be having electrons only in this shell. So 2 electrons are occupied in the innermost shell. Then how many are remaining? 5. 1, 2, 3, 4, 5. 5 are in the water. So to attain the noble gas configuration, noble gas configuration, so it requires how many electrons in the outermost shell? So it needs 3 electrons. 1, 2, 3. These 3 electrons, as we know that it cannot gain it from any other element. Why? Because inside we have only 7 protons. So there will be a repulsion when we give it more electrons. Okay, because inside positive, the outer side negative, it is not now equal. So what it is doing, like other elements like carbon and oxygen, this nitrogen is also doing the sharing thing. It is making the covalent bonds in its own molecule, that is nitrogen and nitrogen. And two, we see that nitrogen is having a triple bond with one more nitrogen. So these 3 electrons which it requires, okay, which it requires, suppose these are the 1, 2, 3, 5. These 5 electrons are present in its outermost shell. Here also we have 5 electrons present in the outermost shell. These 3 electrons, at least it is sharing the 3 electrons of other nitrogen. When this sharing of 3 electrons takes place, so a triple bond is formed. We call it as nitrogen triple bond, nitrogen. Okay, let's come to our man, that carbon compounds. In carbon also, one carbon can share 3 electrons with its own other carbon. It is possible? Yeah, why not? Because 4 electrons are in the outermost shell. Okay, like we have here, this electron, if it is shared by the hydrogen, and these 3 electrons are shared by the other carbon to form a triple bond. So it is possible, we can say that it is actually, the structure is like this. But when we write the chemical formula will be C212 and H2. Am I right? So C2H2. So what is this compound called? There it was called ethene. Here we can call it as ethine. Ethine is the structure for it. So dear students, today we discussed about the basics which are required to study the carbon and its compounds. I am very much hopeful to my students that you understood, because I have step by step how it goes and how different types of covalent bonds are formed, not only by the carbon, by the other elements, and how do elements share to form the covalent bonds with the carbon, so as to make the series of compounds. Those series of compounds we are going to discuss in the next topic. Okay, in next, see what are the different properties of these covalent compounds, which makes them be more in number on the largest on the earth, and which makes them stable. We will try to understand more properties of carbon atom and its compounds. So with this, today I want to conclude this, because our time is going now 45 minutes nearby, so it is more than enough. I think we should not proceed now, because it is getting much larger. It will not be interesting otherwise. Okay, so with this, I am now concluding. Thank you to all my students. I am requesting to go to the NCERT books or state book books and to check this chapter, and to gain more examples and more information regarding what we have discussed till now. Thank you. Goodbye.